Okay, so this is going to be problem 5, the first part, making the chemical equation. So the problem is, how many grams of precipitate will be produced by the reaction of 10 grams silver acetate dissolved in water reacting with an excess of sodium phosphate. Okay, so first thing that we need to do is figure out what compounds we're dealing with. From looking at the problem, we know that we have silver acetate, which is a compound, and we have sodium phosphate, which is also a compound. So we have 2 compounds that are reacting together, so we know it's going to be a double replacement. So, starting with the first one, we have silver. We go to our handy dandy periodic table, and we know that it is silver, so silver is here. And again, we've memorized that this is the little diagonal. It goes 3, 2, 1. So we know that silver is going to have a charge of +1. So we will write that Ag, and then we're just going to write a little +1 next to it, so we know that whatever we're putting with it, it'll have a +1 charge, so no subscript. Okay, so silver acetate. I don't have these memorized, so I'm going to use your little cheat sheet. All right, I'm going to look for acetate. Acetate, acetate, acetate. All right, so acetate. All right, it is down here. It is C2H3O2, I believe that's what it says. We go up here, oxidation is a -1. All right, so we write that next to the silver, C2H3O2, and we know that that had a -1 oxidation, good God. All right. So a +1 and a -1, those are going to cancel out because we don't put the ones as subscript, that, and they cancel out. So we're going to scratch, 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 scratch. So our first compound is silver acetate. Put a little line in front of it, and that's going to react with sodium phosphate. All right, so we start with that compound, sodium. We go to our handy dandy periodic table. We know that sodium is in the first row, so it's going to be a +1. So sodium +1, and that's phosphate. Again, I don't have these memorized, so we're going to look for phosphate. Phosphate is PO4 with an oxidation of -3. All right, so we're going to put a PO4 next to the sodium to make sodium phosphate. We know that is a -3, so it looks like that. Then we're going to take that subscript from the phosphate and drop it in front of the sodium, and then we're going to scratch that out. The sodium is just +1, so there's no subscript on the phosphate, so then we are left with sodium 3 phosphate with no subscript. All right, so since this is a double displacement, we're going to take the silver and it's going to mesh with the other non-metal ion, which is the phosphate. So we're going to put the silver with the phosphate, and remember silver is +1 and phosphate is -3. So silver is going to have the 3 subscript now, and phosphate will not have a subscript. So we get that. All right. So the beginning metal that we have left is sodium, and we're going to mix sodium with the other non-metal ion, which is acetate. So we've got sodium Remember that sodium was +1 because it was in that first column. And then acetate was a -1. Yep. So those cancel out. So it's just NaC2H3O2. All right. All right. So we just took the first metal and paired it with the non-metal of the second equation, and then we took the second metal from the equation and paired it with the first non-metal ion for a double displacement. And so we always know that Ag and Na will be in the fronts, and then the acetate and phosphate will always be in the back because they are the non-metal. Metals always go in front, non-metals go in the back part. All right, so let's balance this. All right, silver, there's 1 on the left side. There are 3 on the right side. So I'm just going to go ahead and put a 3 in the front on the left side and multiply that through and write out the other numbers. So carbon, we have 2 initially. We're going to multiply that by 3 and get 6. Hydrogen, we have 3. Going to multiply that by 3 and get 9. Oxygen has 2. We're going to multiply that by 3 and get 6. For the first set of oxygens. And then we have sodium, which we have 3 of. Phosphate, we have 1. And then we have 4 more oxygen times 1. So we have a total of 10 oxygens. So that first side, I went ahead and multiplied by 3 because we know we have 3 silvers over here, so we know we're going to need at least 3 over here. But then I went ahead and filled out for everything and made sure they multiplied 3 by everything in that compound. Now I'm going to go back on this side and complete it. So I've got 3 silvers. I have that written down. I've got 1 phosphorus. So we're going to put phosphorus is 1. That compound has 4 oxygens in it. Sodium, Na is, there's 1. Oh, well, we have 3 on the other side, so we know we're going to have to add at least a 3 in front of there. So we're going to multiply that sodium by 3. Okay. And then there's that carbon, 2 originally, times 3 equals 6. Hydrogen times 3 equals 9. Oxygen, we have 4 from the original compound, plus we're going to have 2 multiplied by 3 is 6 for a total of 10. So what I just did there was I knew that I had 3 sodiums over here, so I knew I needed to have 3 sodiums over here. So I just went ahead and put that 3 in the front and went ahead and multiplied as I put all the elements down. So there was 1 sodium, multiplied it by 3. There was 2 carbons, so I multiplied that by 3. There was 3 hydrogens, I multiplied that by 3, and then I got 9, which is, those all match up over here. 9 hydrogens, 6 carbons, and then oxygen, we already had it up here. Make sure that we're just multiplying it by the 2 in that compound. 2 times 3, we get 6 for a total of 10 for this side. So let's double check that this looks balanced. Let's check. Silver 3, 3, carbon 6, hydrogen 9, oxygen 10, sodium 3, phosphorus 1. All right, so we are balanced. So we'll throw our 1s in front of sodium phosphate and in front of silver phosphate. So that's what the N should look like. Let me see if I can get it to... Alright, so that is our balanced equation.